Hello students, welcome to EPG Pathshala. I am Dr. Manjula Sharma from University of Delhi. Today we are going to discuss about the module Measurements from the paper Measurement and Instrumentation. From this module, students may get to know about the following topics. First, the methods of measurement, which include direct methods and the indirect methods. Second, the errors in measurements and their statistical analysis, like the absolute error, the relative or percentage error, guarantee error, systematic errors, instrumental errors, random errors, and finally, the statistical treatment of the data acquired. To begin with, what is measurements? We know to measure a given quantity, a comparison has to be made between the quantity and a well-defined standard. The result of measurement is expressed in numbers as it is a mere comparison. For the results to be meaningful, the predefined standard used for comparison must be accurately defined and commonly accepted. Secondly, the instruments used for measurement must be provable. The progress of science and technology depends majorly upon the progress in measurement techniques. The development of new phenomena and relationships in science and technology make the measurements to be further more significant. These new advancements are of utility only if they are backed by actual measurements which prove the authority of a hypothesis. The measurements also improve the understanding of the proposed work. So students, let us see what are the methods of measurement. Generally, the methods of measurement are organized in two categories: direct methods and indirect methods. First of all, let's see direct methods. These involve direct comparison of the quantity to be measured with the predefined standard. The results in direct measurement are given in numerical numbers with a well-defined unit. These are commonly used for the measurement of physical quantities such as length, mass, and time. Say, we plan to measure the length of a bar in units of meter. We can measure the length with a precision of, say, 0.45 millimeter. Thus, due to human factors, it may not be possible to perform very accurate measurements. Thus, the direct measurements may not be used with high degree of accuracy due to human errors. Now, indirect methods. Direct methods are not very feasible and are inaccurate due to the involvement of human factors. Also, the sensitivity is compromised in the direct methods of measurement. Thus, direct methods are rarely used and are generally not preferred. In today's applications, measurement systems are used which are called as indirect methods of measurement. These consist of transducing elements which convert the quantity to be measured in analogous form. The signal is then processed by an intermediate means which is then fed to the end device and the results of measurement are presented. So students, let us see the errors in measurements and their statistical analysis. As we have already understood that the measurement involves comparing the unknown quantity with a predefined accepted standard quantity. A measuring instrument is required to perform this comparison for the measurement. It is understood that measurement of any quantity with full accuracy is not possible, and thus a study of errors is of utmost importance for the study of measuring process. Measurements so performed cannot be classified as good or bad based on their degree of accuracy, but it depends upon the adequacy of the measurements in the provided conditions. In order to understand the accuracy of a measurement, we need to study the different types of errors which may arise in the measurements and how can we deal with them. Now, let us see what are the errors which can be present. First, there can be an absolute error. The true value of a quantity is the value which is observed by making measurements with standards and measuring instruments. However, there is always a difference in between the measured and true or exact value of a given unknown quantity. The difference in between the measured value Vm and the true value V of the given quantity is called as the absolute error of the measurement delta V. That is, delta V is equal to Vm minus V. Second type of error is the relative error or percentage error. The precise accuracy of a measurement cannot be evaluated by the absolute error. For example, an absolute error of 1 centimeter is infinitesimal in determining the circumference of a cricket ground. But same absolute error of 1 centimeter is not admissible for a meter scale. So, relative error is the ratio of absolute error to the true value of the quantity to be measured. That is, epsilon r is equal to delta V divided by V, where delta V is the absolute error and V is the value of the measurand. The relative error may be quoted as a fraction or may be expressed in percentage as well. That is, percentage error is equal to epsilon error multiplied by 100. For example, if R is equal to 100 ohms and delta R is equal to plus minus 10 ohms, thus relative error epsilon R is equal to delta R by R is equal to plus minus 10 by 100 is equal to plus minus 0.1. Therefore, the percentage limiting error, that is percentage epsilon R, is given by 0.1 multiplied by 100, which is plus minus 10%. Third type of error is the guarantee error. The design, material, and workmanship of an instrument defines its accuracy and precision. Which instrument has to be used for a particular application depends mainly upon the accuracy desired in the measurement, and that will ultimately decide the cost to be invested in the purchase of a given instrument. Mostly, the accuracy of an instrument is guaranteed to be within a defined percentage of its full scale reading. Thus, manufacturers of instruments specify the deviations from a nominal value of a given quantity. The limits of these deviations from the true value are called as guarantee errors. It can be said that the manufacturer guarantees or claims that the error in the instrument he is selling is not more than the limit set. The value of a given quantity having a nominal value Vs and a maximum error or limiting error of plus minus delta V must have a magnitude VA between the limits Vs minus delta V and Vs plus delta V, or actual value VA should be equal to Vs plus minus delta V. For example, the nominal magnitude of a resistor is 100 ohms with a limiting error of plus minus 5 ohm. The magnitude of the resistor will be between the limits R is equal to 100 plus minus 5 ohm, or R is greater than or equal to 95 ohm and R is less than or equal to 105 ohm. In other words, the seller guarantees that the value of resistance of the resistor lies between 95 ohm and 105 ohm. Fourth type of error are systematic errors. These kind of errors can be further classified in the following three types: A. Instrumental error, B. Environmental error, C. Observational error. First of all, let us see the instrumental error. These kinds of errors arise due to several reasons, such as inherent shortcoming of the instrument, or due to misuse of the instruments, or maybe due to the loading effects. Students, the inherent errors refer to the inherent shortcomings of the instruments and are related to their mechanical structure. Reason for this kind of error may be due to anything from construction or operation of the measuring device to calibration of the instrument. In order to make precise measurements, one must be able to diagnose these errors, as it is highly feasible to decrease them to a great extent. These errors can be easily reduced by carefully planning the procedure of measurements. One can introduce correction factors in the measurements after ascertaining the instrumental errors. Recalibration of the instrument can also be performed to reduce the inherent errors. Inherent errors in the measurements may also arise due to the mistake of the system operator, such as forgetting to adjust zero of the machine, wrong initial adjustments, etc. Such errors are, however, not fatal to the instrument, but lead to erroneous results and sometimes lead to permanent damage of the machine. Apart from this, loading effects may also arise in the measurements, mainly due to improper use of the instruments. For example, a well-calibrated voltmeter in good working condition may give wrong value when connected to a very high resistance circuit, while the same voltmeter would provide correct values when connected to a low resistance circuit. This explains that the voltmeter has a loading effect on the circuit. The environmental errors. These errors are related to the conditions of the surrounding area of the measuring device. These external effects include temperature, pressure, vibrations, dust, humidity, or the external magnetic or electrostatic fields. Several corrective measures can be employed to reduce these kinds of errors. One may try to keep the ambient conditions as stable as possible, such as by keeping the instrument in a temperature controlled closure. Resistor materials should be chosen in such a way that they may have very low temperature coefficient. Also, one can hermetically seal the instruments so as to reduce the effect of humidity. Observational errors. These are mainly related to the human errors. For example, the parallax errors which arise in voltmeters, where the pointer of the voltmeter rests slightly above the scale. To avoid this kind of error, highly precise voltmeters are present with mirrored scales. Also, voltmeters can be used where the scale and pointer are in the same plane. Also, modern electrical instruments are provided with digital displays, and hence the observational errors are completely eliminated. The fifth type of broad kind of errors is the random error. It is always observed that the experiments show difference from one reading to other, even when we have already removed all the possible errors from the experimental setup. These kinds of errors occur due to a variety of factors which change or fluctuate from one measurement to another and are just due to chance. Our measurements are influenced by several known and unknown factors. All the disturbances about which we are unaware can be classified together as residual or random errors. As these errors stay intact even after removing systematic errors, these are called residual errors. These errors are variable in nature and do not follow any defined rule. Now students, let us see the central value. The random errors are caused by several small and variable factors. These variables may be either additive or subtractive in nature for the given value of quantity to be measured. If the positive and negative effects in the several measurements so taken are nearly small, then the resultant errors are small. If we have taken a large number of samples and the plus effects are equal to the negative effects, they shall cancel each other and we would obtain the scatter around a central value. The effect of random errors can be minimized by taking several measurements of the given quantity under same conditions and taking their arithmetic mean. This mean value can be considered as the most probable value of the measured quantity. If the errors are truly random, a plot of the readings gives a typical error curve. Now students, let us see the statistical treatment of data. The experimental data is generally obtained in two forms of test. First, the multi-sample test, and second, the single sample test. Multi-sample test. Repeated measurements of a given quantity are performed using different test conditions, such as employing different instruments, different ways of measurement, and by employing various observers. Multi-sample test doesn't mean to make measurements with the same procedure, technique, equipment, and same observer. Single sample test. If a single measurement or succession of measurements is performed under exactly same conditions except for time, then it is called as single sample test. So students, let us summarize what we learned in this module. In this module, we studied the various measurement methods, that is, the direct methods of measurement and the indirect methods of measurement. Direct methods involve comparison of the quantity to be measured with the predefined standard. Thus, due to human factors, it may not be possible to perform very accurate measurements. Indirect methods of measurement consist of transducing elements which convert the quantity to be measured in analogous form. We also studied the errors in measurements and also their statistical analysis in this module. In order to understand the accuracy of a measurement, we need to study the different types of errors which may arise in the measurements, and also we need to understand how can we deal with them. So we studied the various kinds of errors useful in the making of measurements, such as the absolute error and relative error or the percentage error. We understood that the absolute error is generally not used as its applicability varies with the dimensions to be measured. So the relative or the percentage error comes more handy as compared to the absolute error. We also discussed the guarantee error, which are specified by the manufacturers of the instruments. They specify the deviations from a nominal value of a given quantity while selling their instruments. The limits of these deviations from the true value are called as guarantee errors. We also studied about the systematic errors in detail, which constitute the main kind of errors and can be further classified into three categories. That is the instrumental error, the environmental error, and the observational error. We also studied how we can remove these kind of errors. We also discussed that our measurements are influenced by several known and unknown factors. All the disturbances which are unaware can be classified as residual or random. Thank you.